This project is about semi-supervised named entity recognition for noisy text. As we know that generally named entity recognition corpuses are trained on news data which is structured and labeled, and the syntax of all the words, syntax as well as grammar as well as spelling of all the words is accurate. But when it comes to noisy text like Twitter data, social media data, the spellings are not followed. A lot of out of vocabulary words are found, and when an NER classifier is trained on such data, you get very sparse matrices as well as dimensions. So that's why this paper has been written. Let's run the Jupyter notebook. So just to get a path of where we are, so the main folder is called Twitter NER, and within that there is a folder called Noisy NLP where all the refactored code is present. This just imports the file, the child class as well as the other modules required. The main interesting part about this paper is that it uses unsupervised as well as supervised data. So the train, dev, and test files are files that are the supervised data, that is, they are the labeled files, whereas they have other features like vocabulary files, word vector files, dictionary files, and Brown and Clark clusters, which is all unsupervised. And as and when the model trains, it learns from this data. So the program requires you to give the paths of train, dev, and test files as well as all of these unlabeled data where it can that it can use to learn. Then we call the read dataset method. The read dataset method takes as input a file dictionary which consists of train files, dev files, and test files, and it also takes in the vocabulary file. The dataset name can be specified. The dataset that I have used is the Walnut 2016 dataset, which is the benchmark dataset for my paper. I have also run this program for Cornell 2003 and Onto Notes, the results of which are present in the README file as well as presented before. So the read dataset outputs the number of sentences in the train file, test file, and dev file. This is a small file for now because Twitter takes in, there's not much data available. So like we can see, the number of testing data is much higher than the number of training data, and that's a challenge we have to overcome. The training takes quite some time, and which is why I will not be running it now, and instead in my predict method I will be calling a pre-trained model. So using the load method function, I'll be calling the pre-trained model, and then I'm passing the input path for the test case. This was common for the group, and these are the results that we get. So initially it loads all the dictionaries and other unlabeled data that it needs, and then it returns all the entities with their start and ending tags. So 66 to 69 was other, 70 to 71, so word present at index 70 to 71, this word was a geolocation, and similarly these entities have been tagged out of the data. The output file is also an output file is also generated by this predict method, which is again given in the test folder in the noisy NLP folder, which conforms to the format of word followed by actual tag followed by predicted tag, and which is what is used to run the sample test file as well. And then when we run the evaluate method, we get so it evaluates on every file. It evaluates on all the test as well as train as well as dev files. So we are most interested in the test file, which gives us it says that it's processed around these many tokens, and precision, recall, and F1 values are given over here. These are the final values for the test file. Similarly, they've shown the results for other train, dev, and yeah, the other train and dev files. Thank you.